Hello everyone, it's your friend Oliver and Alex reporting from the Consumer Electronics Show 2026. Now, we have not been on the ground for too long. I think I got in last night at about 4 p.m. Alex got in at about, I don't know, God only knows, 10 p.m. It's very late. Alex also came in after a 20-hour flight. I only had, I think, about a 3-hour flight from Vancouver, BC. A lot easier. But we did actually see something earlier this morning at the Nvidia booths at the Fontainebleau Hotel. And we saw some very interesting things. Now, some of these details have already leaked out in the public, and I'm sure some of them will also be quite evident to you by the time this video is published,
right?
Because I think we're going to be after embargo. But we have a series of new announcements here today. The first of those announcements being DLSS 4.5 and its dynamic frame generation solution as well.
Yeah.
So I think this is really important, right? Because last year we had the very first Nvidia transformer-based DLSS model, DLSS 4.0. We were extremely impressed by that last year when we saw it at CES 2025, which was, of course, a year ago, alongside, of course, AMD's innovations in the image reconstruction space with their FSR4 upscaler. Very impressive as well. So DLSS 4.5 basically aims to iterate on that original transformer-based model from Nvidia, and I believe it was trained with 5 times as much compute. Brian Catanzaro talked about this in a promotional video, and it's a very impressive model, and it seeks to shore up, I wouldn't say the weaknesses of DLSS 4, because it didn't really have strong weaknesses, but I think it just aims to improve and iterate on that underlying model to actually achieve really great image quality in games. Wouldn't you say so, Alex?
Yeah, we saw it essentially running in multiple games, but the most important one that we saw was Black Myth Wukong. Yeah. Essentially, we had 2 monitors side by side, and the ability to, with the stroke of a key on the keyboard using the debug version of DLSS, one of the DLLs there, 0 and 9 key would switch between the old K model and the new, I believe it was M model, as they call this, the 4.5 version. And there were actually really immediate differences, and there's a number of reasons for that. Things that they've already shown in promotional video pieces, like if you looked generically at something like, for example, plants in the background, you could see that they were more easily stable in the newer version. Very easy to see that difference there. You could also, interestingly, this is the most different thing, if you look at a lot of areas where light interacts with an edge, like a specular highlight shows up, the difference is actually quite large. One, the aliasing is a lot less there, but also you're just kind of seeing like a larger specular response. And normally we would imagine that those things, the aspects of those in image quality are based upon like, oh, how is the ray tracing being denoised? Or, oh, is there like a brighter light source there, like an analytical light source? And the answer is no here. What they're doing now is that I believe the area in the frame, or the thing that DLS accumulation is occurring at, is pre-tone mapping now. So they're not so the average results you're seeing from accumulation are not going to be compressed and clamped anymore. Rather, that's going to happen after it. And in this case, that allows for it to actually bring out more accurate details that were already in the image before, that were always there, but the kind of the image was being compressed. And so you can see that in aspects like the area behind here, behind the main character, on the wall, you can see that there's these like little graded openings leading to the outside, and a lot of them are kind of disappearing due to the tone mapping from before, and now you can actually see them. Another aspect that they pointed out pretty well that is partially relevant to this kind of more accurate to the ground truth of the image is the particles that are flying through the air. Now, particles are actually done pretty well through DLSS in the past, I would say, actually pretty much in all versions of the model. But in a game-to-game basis, they could be better or worse. And this new model is much better at bringing it out in games where they were more problematic. Like, for example, the fireflies here around the like little Buddha statue on this table here. But it does look to be resoundingly improving kind of, you know, the little gripes you would have with the original Transformer, while also adding in new bits. And they showed it here running, I believe it was on an RTX 5090. if I'm not mistaken. And they did emphasize, though, that the new model is slightly more expensive than the previous one. I think the quoted figure was like 2 to 3%. We'll see when we actually test it out ourselves. They say that, so it's a little bit more expensive, and we saw it on a Blackwell card. But the fact that it's a transformer model, though, makes me think it could potentially be more expensive on Turing and Ampere than what we saw here. But once again, this is something you'll be able to adjust on a per game basis. If you don't want to run the transformer because it's too expensive for you, you can always turn that off. That was altogether really, really cool. Very easy to see differences just by flipping back and forth. In fact, I did recommend to them, I was like, you guys should make that like something users could usually do, because it'd be really easy just to see how much better the model runs. But so it is.
Yeah, I thought this was really cool because, like, to me, I never really found that DLSS 4 was like lacking in any particular sense relative to other upscalers. But then you see this next step, this next iteration where they're really getting like a super fine particle resolve, or the shadows look super crisp and super great, like in that Buddha statue, or whether you're looking at like distant foliage and it's resolving much more cleanly, or like the tone mapping issues that you pointed out earlier that created some problems, but again, were they really problems? I mean, Nvidia obviously has access to like super high resolution ground truth images that they're training on, so they're actually able to get like this much closer approximation of that ground truth result here, which I found very, very impressive, and it certainly is looking considerably better in some of those areas that before you might not have said, oh, that's deficient, but actually it turns out you can get this much nicer specular response, you can get this much nicer particle resolve. So that's like really cool.
Yeah.
Another aspect of Nvidia's new DLSS announcements today is their DLSS 4.5 dynamic frame generation solution, I believe.
Yeah.
And by the way, actually that earlier example we saw was running with the 6x frame generation, I should point that out, as opposed to the 4x, which is on the other end. So we're looking at an improvement in frame rate as measured by these on-screen statistics of like from like 190 before, it looks like, to about 250, 260 now, which is, I mean, that's crazy. And then there's some increase in latency, but it's so minuscule on this card. It's on the order of like a few milliseconds. I think it's quite minimal relative to obviously that massive increase in generated frames, 5 generated frames for every 1 real frame. That's pretty extraordinary there.
Yeah, it's
that
great.
Brings you up to like some crazy multiply, I imagine.
Yeah, I think since it is a new model, it is not so expensive.
Yeah.
And so they're able to punch in more frames there without increasing latency so greatly, which is great. And the next demo too, we saw this is running in one of Alex's current least favorite PC ports.
Yeah.
This was the Outer Worlds 2. One, they also showed the difference off between the old Transformer and new Transformer model. Like side by side, you can see that the stars become brighter in the new one, which is interesting because they're kind of being over-averaged in the old model. And that's something you see happening with a lot of TAAs, actually, that you wouldn't see in a ground truth image. But then the demo, essentially, you're going through the main ship in the game. And as you walk through it, this was running on an RTX 5060 Ti. Yeah, 16 gigabyte version, 1440p if I'm not mistaken, in performance mode. And I think they wanted to show basically as you walk through the ship, varying levels of GPU load will change the multiplier. We saw it going from 4, 5, 6 times down to maybe 3, I believe, when we looked out a specific window, as the GPU is not troubled by looking at empty stars. We're watching these on, really great G-Sync displays. I didn't notice a difference. We'll have to see what it's actually like when we take it under the, like the microscope, or also just more time with the game. One thing that we were told very specifically is that if you are dropping due to like varying levels of load, like say one area of a game without frame generation runs at like 200 FPS, and you go to another area that runs at 50 FPS, you're going to immediately feel, even though you may not see a great difference in fluidity of frame rate, because generated frames are actually pretty good, you would definitely feel the difference in real input latency, because that is a large difference, actually. This was more, I wouldn't say this was hands-off, we were doing it ourselves, but this was also very cursory. We can't exactly say definitively certain things about it. Some other things to say about the demo. It was using Lumen, and so there was a lot of noise, and you could sometimes see that the new model would produce a different noise pattern than the old model, essentially.
Yeah, but it was like still problematic in both models, but that's really speaking to the quality of the input and not as much the ray reconstruction.
Yeah, no, it's 1440p DLSS performance mode has like a 720p internal resolution, and Lumen is already very noisy in general.
Yeah.
So that's kind of what it was.
Yeah. So that was pretty cool, and I think ultimately, like, this new frame generation technology, I wasn't looking at Nvidia's old frame generation technology and saying, this is lagging behind competitors. Like, it felt like a really high quality frame generation, probably the highest quality frame generation out there. But this just increases the multiple in the frame generation to get you like to some truly ridiculous refreshes, even in, AAA software. Although I would say Outer Worlds, one key caveat with this is that we were seeing the game just in its introductory area. I imagine if we were actually seeing the game out in the open world on one of those planets, that the stuttering,
stuttering would show through.
These behaviors would probably show through, which is unfortunate. So Outer Worlds maybe not the best game to show this off, but actually in this limited demo area, it was very compelling. And I think the frame generation differing in the moment, it didn't really seem like you could actually tell that too much.
No.
In terms of the input response, it felt fairly static.
It feels fairly static, at least in this scene. Another thing to point out is that technically the model does have some differences in terms of quality. I think Nvidia isn't talking too much about that, but we were specifically told that UI handling will be done differently. So for like semi-transparent elements, there may be like a separation now that is made available to DLSS that it can actually respond to better. And so areas behind semi-transparent UI elements will reproject better into the current frame, into the future, as you would say. And at that moment, that means technically we'll have to test this out to see if this is true, of course. But since we didn't see a great side-by-side of this, that things like cursors or, aiming reticles or, sideways widgets on the screen will not, when you spin the camera, have potential ghosts in them or as much, or the info behind them may reproject better. So we'll have to see that. That's one thing we'll have to see when we test it out ourselves. So
yeah, and I think moving on maybe from the Nvidia stuff, briefly just talking about a game that makes use of all of these technologies in some interesting ways is Pragmata, the new Capcom title, RE Engine title. Very cool looking. Obviously, there was a demo of it at Gamescom. There is a public demo, I believe, of the game currently. And that is a game that previously we were kind of a little curious about because it seemed like they were using a lot of ray tracing, but they were not using the RE Engine path tracing. Well, it turns out they are using the RE Engine path tracing, which is pretty cool. So I think the biggest difference here, now there were some issues with the demo that we expect to be corrected in time. If not, even by the time of this video's publication, they may have been corrected. Yeah. It sounds like they're doing some work on site. But to me, at least, the big takeaway from this demo is like the reflections look great, obviously very clean with the ray reconstruction. The GI looks pretty good. But obviously the big change in this demo relative to RE Engine typically is that the shadows are like extremely precise and extremely clean. Out of RE Engine, what we're used to seeing in the shadow presentation is like super alias, super sawtoothy, not very stable. It's one of the characteristic weaknesses of RE Engine, as well as I would say the SSR in RE Engine. Yeah, really. Although obviously the SSR is not a factor when you are ray tracing the lighting there, when you're doing ray trace reflections, I should say. But yeah, do you have any comments on this demo? Yeah. And also maybe some comments on some of the unique elements, the appearance of DLSS in this title?
Yeah, so in this one, it was a great surprise to see because it wasn't announced beforehand and it was just like told to us like, oh, we're going to be running Pragmata here with PT, which is great. Makes a lot of sense, especially for this with the hard sci-fi environments in the game. Yeah. Arguably almost more than Resident Evil. Yeah. Because, it's like essentially made of hard plastics,
super
metals.
Artificial and glassy and a
lot of glass everywhere too. Yeah. Some really nice funhouse mirror kind of glass looking stuff in it. In general, like you said, the demo we had some sort of issue with it at the moment. They were trying to fix before they brought it out to a more public demo, where there's extra like fireflies all over the scene when you sit still in the lighting presentation. So hopefully that's fixed by the time this is out. It does actually remind me a little bit of an issue that we saw back when we saw Resident Evil Requiem earlier this year. I wonder if there's some sort of issue right now in RE Engine in general. But that looked pretty great. We also saw in the reflections themselves too, they they're actually reflecting almost everything in the world. And interestingly, the Capcom games now start using strand-based hair.
Yeah.
And even that was reflected in the reflections. I don't know how, and it was also moving. It was dynamic in the reflections. It wasn't like a static thing. So it'll be interesting to see whether or not this is using the quote-unquote RTX hair.
The linear swept spheres, is that it?
Linear swept spheres, which is like a simplified representation. Instead of just using geometry, you use like a bounded sphere kind of thing. And you can really represent like elongated tubes and stuff like that, which is what you would use for hair here. I don't know how they're doing it. I don't know how the lighting on the hair was done here, but it seems like it would be a great title to try it out on if they were doing it. But otherwise, it was reflected in the reflections. Looked great. Really love the tight shadows. DLSS 4 kind of stuff in here. I mean, it was running really fast. I didn't notice any image problems beyond the noise that we talked about mainly. So we'll see if that fixes up for the final product. But this is like, I believe, late April. So we'll hopefully have a lot of good core coverage of that PC version. I'm happy that it's going to have PT in it, because originally I thought it would just be the RT reflections and RTGI, which is already a great thing. But having that extra layer now in a sci-fi environment makes so much sense to me.
Yeah, actually, initially when I was looking at this demo, I thought that the artifact patterns that stem from, something inputting to the ray reconstruction there, I thought they were kind of intentional, because it looked to me like almost like an old-timey film grain where you have those splotches, like if you're watching a movie from like the 1940s or something.
Yeah.
But they are not actually intentional, which should be pointed out in this footage. But I think otherwise it looks terrific. Obviously, the shadow presentation, those super crisp shadows, even on like tiny little bits of like newspaper scattered around, that looks really cool. Again, it's like very unlike what we're used to seeing from RE Engine, so it's great to see the application of some very advanced technology here being put to the, obviously with ray reconstruction, obviously with the path tracing, actually greatly improving this game's appearance. And it does look quite handsome, I'd have to say, in addition to RE, which I think is the new Resident Evil Requiem is coming out in February, I believe.
Yeah.
But there's another aspect of Nvidia's technology stack here, which is not actually necessarily related as closely to DLSS, but it is the RTX Remix technology.
Yeah.
And I actually did not hear too much of this. I think you heard much more of this. But there's a new kind of RTX Remix, how would you describe it, logic system that they've got going on?
Yeah, basically without having source code access to a game, based upon the things that RTX Remix can already plug into, like in the graphics API, that it's emulating and putting back, it can change parameters inside RTX Remix to add dynamic elements to games. Now, this could be great to cover things that previous games, like when you insert RTX Remix into a game, old games would use like, rudimentary post-processing effects, or they would, add a screen overlay at a moment. RTX Remix actually doesn't have a great understanding of those things necessarily, because they are not just like standard geometry in the DX7 pipeline or something like that. And here with this, you can kind of make trigger events, like flow graph style trigger events, to change things in the world based upon player input or game condition input. And they showed a variety of ones. I don't know which ones the public will have seen, but they have the ability to, like, you open a door in one scene and it changes the time of day and weather, and particles spawn, and you open the door again and it's a different time of day, different particles, different everything. Yeah. They also added one that's like enemy and player viewport aware, like you get close to a headcrab zombie. Now, this is not things that they're going to put into Half-Life 2 RTX, by the way. This is like they're trying to show off what things are possible. Like you get close to an enemy and you turn around and it has like a pulsing chromatic aberration effect when the enemy's closer to you. They're like pulsing the vignetting and adding chromatic aberration. It's pretty cool. And they also had, I think the coolest one though really was so it's like adjusting the parameters inside RTX Remix, and like you go into a hallway and there's this little thing that he picks up on the ground, and it's adjusting the like the virtual height of parallax occlusion maps. Yeah. And it makes it look like the walls are undulating. The mapping displacement factor, I think you said. That was awesome. First of all, I didn't realize all that stuff in the environment was POM in general, so that was cool. I was very surprised. Yeah, I didn't expect that. I thought that was just like Geo that they added in, but so that says the effect is good. But so they're showing it off here in like very obvious gamified ways, so that a presenter can describe it to you.
Mm-hmm.
But the real reason people would do this is because they want to have kind of like greater control over their modding experience, and also represent things in the modded experience that the game originally did, but are hard to do with RTX Remix currently. But also, if you really wanted to, you could add like new gameplay effects and gameplay features now with RTX Remix, which you really couldn't before. So at least without source code access.
Mm-hmm.
So that is really awesome to see, including this, the zombies being like electrified and burning away, which is, they said that is an example of them modding the game source code wise, as well as using this RTX Remix Logic.
Yeah, for the fire, they're like modifying the source code, and then everything else is through this new RTX Remix feature. But Alex, I think we have kind of two more general topic areas we wanted to talk about today. The first is probably G-Sync Pulsar. Now, G-Sync Pulsar, very interesting kind of strobing technology. We'll try to reduce motion blur, apparent motion blur, perceived motion blur, down to the lowest levels possible. Now, unfortunately, because of the nature of cameras, because of the nature of shutter speeds, and indeed because of the nature of the G-Sync Pulsar technology itself, this does not photograph well, so you'll just have
photograph
to
at all.
Take our word for it. Indeed, when we turn up the shutter speed, when we really have a fast shutter, you can see that all of a sudden the G-Sync Pulsar display is showing some kind of almost like PWM flicker behavior. But in person, that behavior is not at all noticeable, I would say.
No, it isn't.
And one
at
thing
all.
you can also notice in some of this footage is that actually when you have the G-Sync Pulsar display and you have this really fast shutter, the G-Sync Pulsar display is like very, very bright, but kind of intermittently flickering in there.
Mhm.
The other display is much dimmer. So kind of describe what this looks like in person, because obviously we don't really have great photography of this. But I would say that the appearance of motion blur, even though it isn't bothersome to me, you definitely do get a lot less of that kind of persistence blur, that kind of unnatural blur that you really don't want to see in games, especially when you're like scrolling past or indeed tracking objects or tracking text in games like Overwatch.
Yeah, we saw this running in Anno, and we also saw it running in Overwatch.
Yeah.
The generic appearance is that, well, there's two things. One, like you just said, G-Sync Pulsar looks like in some of this footage of yours brighter than the monitor next to it. Ignore the flashing. That is not something you see in real life.
Yeah.
But in person also, it is a slightly brighter presentation than the other image. And I found that
very
interesting.
Bizarre.
I didn't expect that, because usually when you pulse a display or you insert black frames, etc., you expect that it would be darker, and it wasn't darker. So G-Sync Pulsar does not dramatically darken the image or anything like that, not at all. So that is different. That is different than current BFI technologies that you've seen in the past. So it's very different than what you may have access to on your television. Another thing that this does that was when it was originally announced, arguably most interesting aspect of it is that it works with VRR. It is varying the refresh rate, and it is also having the strobe behavior to reduce motion blur. In person, I found the motion blur reduction super obvious because I'm one of those weirdos who's attuned to this and I like it. It's going to be on a person-to-person basis how much you notice it, but it really does bring it into that CRT level. It's pretty obvious to see if you've used CRTs a lot. The difference, obviously, this is an IPS monitor. The way they do it is very interesting, and as was described, that I believe there are 10 vertical stripe zones on the left-hand side of the monitor, as they say, and it's going from bottom to top, rolling it, and it's kind of like, it's bright here. It's kind of like a scan line going up the image, and they're brightening, darkening, brightening, darkening, brightening, darkening. And that's why you see this flicker, this interesting strobe flicker here. But the thing is, this is different than technology of the past, because usually the entire screen would be flashing.
Right.
And that gave a very different persistence presentation. And it made first of all, the darkening, and it would make the flicker more obvious. But here it really, makes it so that it's very bright, and also has extremely low motion blur, persistence blur. I can only talk about it so much. Like, you had to have been there to have seen it. It is obvious in person. It is less blurry, and it's not blurry at all, actually, and it's great.
I totally agree with you, Alex. Actually, the thing that I really notice is like when you're tracking things, when things are moving across the screen, you really don't notice that difference. At other times, if you're not really focusing on the screen, if you're not focusing on individual objects, you're not going to notice as much of that difference. Indeed, like for me personally, obviously I'm known for my love of very bright displays and in many cases slightly laggy displays because they are like VA LCDs that have some of that kind of smearing characteristic to them. And I love motion blur. I love software motion blur.
Yeah.
Other people have different proclivities. Indeed, the person we were talking to, a nice German fellow, said that he really didn't like motion blur in games. So obviously everyone has their own different sensitivities and different tastes, but I know that John, for instance, is quite interested in these monitors, and I know that you're very interested in this
Oh,
stuff.
yeah,
So,
too.
yeah.
I did ask, I was like, so this is currently running on an IPS. Have you thought about OLED? I mean, it just occurs to you, right? And they did mention that is on their radar and that they are looking into that. So the ideal perfect monitor may exist in the future at some point in time that allows you to have VRR, allows you to have OLED advantages in like contrast and whatnot, as well as low persistence, extremely low persistence. So
Yeah.
we'll see.
And another kind of like the final round of demos I think we have to talk about today is NVIDIA's various machine learning demos. Now, basically what they're doing here is they're taking a game, or they're working with developers to add basically machine learning, add LLMs, add text to speech, add speech to text, add different kinds of models into games that hook into game logic in order to improve your experience. So we had two demos here. The first demo was a demo of the game Total War Game, the Pharaoh's Total War Game. That was pretty interesting. It was basically like this tutorial helper where you're typing in commands into this text interface, and the little helper is telling you information about the game, giving you advice about the game that actually reads from basically the game state and is telling you things that are relevant. So like, how do I prevent a rebellion? Or how do I move these units around? Or how do I defeat this army? Is my army more powerful than this army? Is it likely to defeat them? Things like this as kind of a tutorial helper in this game to basically facilitate the kind of player onboarding experience.
Yeah, and this was the most compelling demo, and I think it's actually a great usage for machine learning. It's important to note that this was all running a local model on the GPU, with a certain how many gigabytes, I can't remember off the top of my head.
I think they said about 6 gigabytes currently, but they're working with different models. I think they mentioned they were working with a few different models, potentially the Quen model series as well.
Yeah.
And they like, NVIDIA likes this new terminology, and Microsoft likes this new terminology of calling them small language models. But this is actually just like, it's, to me, it's a little bit misleading because it's like, okay, well, you've taken all of the data that's almost ever existed and you've trained a model on it, but it's a smaller model, but it's still like multiple gigabytes in size. And it's like, these are large language models. Small language models is a bit of a branding, but it is true, certainly, that you are getting the capabilities of what might have been fairly large parameter models that might have had, 70 billion parameters or something, maybe a year ago or a year and a half ago. And you're actually getting that capability in a model that might be 1/35th, 1/30th, 1/40th the size, which is pretty impressive. And indeed, the capabilities of these models in this game seemed like it was giving reasonably good advice. There were some quibbles occasionally with the advice it gave.
Yeah.
Mostly they were pretty good.
Yeah, it's basically, if you've played an RTS game before and you're doing like the first couple missions and stuff like that, there's usually someone there telling you what to do on the side that pops up, and it's not always so great, and it doesn't give you great context always. But here it was actually very contextual since it's directly plugged into the game, and I actually really did like I asked the person giving us the demo, could you ask the model why this is the thing that they're recommending? Because like why is my army weaker than the rebel army? Because it just stated it as if it were a fact, and then it listed, oh well, you have less elite units than them. You should buy this, and this is actually really good. I actually thought like really like, I'm actually pretty skeptical about the real-time usages of these kind of things in games until I see some like really great killer app use case. And I think this direction of helping players by leveraging in-game databases that are already there, that are already managed by the game itself, just makes a lot of sense, because there's all this information games that have running in the background that don't have a UI that you can now make more accessible to the player so they understand the game better. And I think this made a lot of sense.
And it's all information that's just like sitting there in a database that's like just a big wad of text, which is what LLMs love to process. They love to deal with massive quantities of data and to distill that out into a format that's actually recognizable to the player and actually helps them, especially in the onboarding process for these games. Because I don't know about you, but I'm not a big fan of games that have very lengthy tutorials. But this seems like it actually could be more interactive. Instead of reading through some book to figure out what's going on in the game, you could just kind of like play it by ear and learn some things along the way and get some help from your friend. There was another demo here that I thought was also very interesting, perhaps with more applications for kind of actiony games, which is this kind of like simulated virtual NPC in the game PlayerUnknown's Battlegrounds, I think. PlayerUnknown Battleground, PUBG. And this was pretty cool. I think they did run something like this. I think we saw something like this similar last year. But the big change here is that they've moved from running models in the cloud to running models that are running on device. So they have speech to text because you're actually speaking to the game. Then they have an LLM in there, or in their terminology, perhaps a small language model, but an LLM. And then they have a text to speech model, and it's producing like pretty good input into the game. You're getting a very sensible, it seems like, LLM response that's giving you information about like, oh, maybe you should go here, maybe you should go there. Can you give me your M16? Can you do this? Can you do that? It's responding. It's actually behaving in-game in accordance with that response. And it's spitting it out in a reasonable kind of text-to-speech voice that sounds very computerized, but is like totally understandable and pretty good, I would say.
You can understand the enunciation. One thing that I noticed different than last year was also faster.
Right.
Like the response time was faster because it was local.
Yeah.
So that's another thing. Like this was not using cloud-based responses, so it was pretty much nearly immediate, unless the model had to interrupt itself while it was speaking or something like that. So that was pretty good. I mean, wouldn't use this because I don't play these games. We'll see how it is. Another interesting thing about this demo that I thought was cool is that we saw it running on a high-end GPU, but if I recall, when this is a Crafton game, I believe when they roll out the feature, they're actually going to be targeting even lower end, like
they said 3060.
3060.
I don't know if that's 3060 8 or 12.
8 or 12. I don't know if it's 8 or 12 or if it's using the exact same like model size, etc.
They said that the LLM, I believe, was would use about 2 gigabytes of memory.
Yeah, they said it was very small.
It's quite small, but I mean, again, you can kind of mix and match models here. It's not like they're committed to any particular model. And it seemed like the responses they were getting out of it, even though it was like a pretty small, low parameter model, were pretty good. I was very satisfied with that. And they also said that the performance impact was low. I mean, if there was any performance impact, God only knows, because I couldn't really detect anything that was less than super crisp and super smooth, as we're used to seeing with these Nvidia games with like MFG and all this other stuff going on. So I think it's pretty cool, and it's a way of like showing how AI can work in real time to give you a kind of gameplay experience that you would have never seen before. Like obviously there are like these natural language systems, NLPs, natural language processing, which you've had for a while. You might think of a system like Siri, for instance, which responds to like a very limited number of commands, has very poor understanding of human language, has no flexibility. But this system is just like almost infinitely flexible. You can give it different kinds of commands. It can understand you. It can translate that to game inputs. It can translate that into game actions quite well. And it's just a really cool thing to see. So I'm definitely on board with this kind of thing. And if it's running locally, that only adds the prestige for me, because it's not just like querying some, server, querying Gemini in the cloud. It's actually running on your PC, running on your GPU. I think they said that Crafton was going to use the same models for all players. I think it's kind of an interesting approach because, perhaps for your, RTX 5090s out there, you could actually use a larger model.
You could, arguably.
Yeah. Or you could use a smaller model, obviously, for very impaired GPUs. I think right now there are like 1 billion parameter models that could do an okay job maybe with stuff like this. That's worth considering. And then Alex, I think as one final message here to the audience, we did ask about some recent rumors that have been floating around, perhaps of unclear provenance, that have been floating around on various sites on the internet. We know there are lots of sites and there are lots of rumors out there, and we know that the gaming industry is currently under an immense amount of pressure, I would say, for like semiconductor resources, for RAM, for for wafers potentially, from the AI industry and from other consumer industries, as has always been the case, but certainly from AI, which is a massive center of demand. So we had 2 stories come out basically about the 3060 possibly re-entering circulation potentially. Obviously the RTX 3060, very popular card. I think it's the most popular card in the Steam hardware survey. And then there's also some discussion about RTX 5090 pricing, because recently we've seen somewhat higher prices than usual for 5090s. I know that a friend of mine recently purchased one for about 3,300 USD. We've seen higher listing prices than that. So what kind of comment did we get from Nvidia on those developments?
Yeah, so we asked about this specifically and about the return of the RTX 3060, and the response was, well, the RTX 3060 never left us in the first place. Nvidia has actually maintained and kept selling them ever since it released. So that actually hasn't changed. So there isn't going to be some larger announced return of it, or like some like official MSRP or a Founders Edition version or something like that. It's just going to keep being kept on made. That's kind of what it is. So there actually isn't anything new to report there. You could have bought a 3060 just now. Regarding the 5090, they said that there is no announcement for a change on MSRP there. And they kind of said like changes in price that are occurring are kind of fluctuations that occur on websites. I
mean, ultimately, there are resellers.
The resellers,
who can price at whatever price they see fit, and there's supply and demand. And we also know that, I know that there's some demand from professional users, some demand from AI users for 5090 cards. Maybe that's being driven up, but that's obviously kind of separate from the industrial data center use that are using
it's
totally different, right?
It's different, and on a VRAM that is even used for those things, or just different use cases
totally
in general.
Yeah.
So I don't think that is the pressure there. In general, they also just mentioned that there are currently no announcements to be had about changing of MSRP for FE models or anything like that. So it seems actually from that perspective a bit more business as usual, which is a bit surprising.
Yeah.
Because in light of, like we saw with who was it, ASUS, announcing the kind of increase in price of their products that are affected in the future. Doesn't seem to be the case on the Nvidia side right now, based upon everything we just learned today. So
yeah, and there's also no changes, as Nvidia has made abundantly clear, in terms of their lineup, right?
No.
So it's still the RTX 50 series lineup. It's still the same lineup as we saw last year. There is no announcement of any kind of RAM boosted Super series, as has been rumored for quite some time now. We don't know what the status of that line is, or indeed if it will be announced anytime soon. It's certainly not at CS, it seems. But yeah, I think we saw some pretty cool things from Nvidia. We were also able to get some comment from Nvidia on a couple of other matters.
Mm-hmm.
But I think this is pretty cool, the overall lineup here. We've got DLSS 4.5, DLSS 4.5 dynamic frame generation, the new changes to RTX Remix, G-Sync Pulsar, the new machine learning additions to games with the new additions in PUBG and Total War, and obviously Pragmata getting path tracing support.
Yeah.
That's very cool. So I think we've seen a number of really interesting technologies from Nvidia today. A little bit of a lower profile year than last year, where they had a big blowout with
huge
DLSS 4, with Blackwell, with everything. It was so crazy. It was so cool. Huge Jensen keynote. There is a Jensen keynote this year, but it's on not on consumer stuff as much. I suspect it's about things that are maybe more relevant to Nvidia's stock price.
yeah, that's what it seems.
Yeah,
it was pretty cool. I'm from everything we saw today, I was just very happy to see DLSS kind of not sitting on its laurels. They are iterating on the model. I hope to see also, since we saw FG and SR today, I hope to see in the future not changes because they're so necessary, but see ray reconstruction also advance in other categories, even new technologies that they didn't even talk about. Who knows what we'll see, but it's good to see it's advancing at least and not stagnating.
Yeah, that's really exciting. So, Alex, I think that's probably going to close it out for today.
Mm-hmm.
I think we've had a really good time at CES for the first big day here after our flights in, and I think we have a lot more interesting content planned. So at the time you guys are seeing this, we'll be on the prowl, looking for stories, looking for things of interest to show to you guys, hopefully in due time, hopefully sooner rather than later. I think we're planning a DF Direct here.
A Direct.
Doing lots of different things, hopefully some other content you guys will see in due course as well. But if you did like this content, please like, subscribe, and press the bell for YouTube notifications. Check out the Patreon at patreon.com/digitalfoundry for exclusive and early access content. And to get in touch, please use social media as per usual. And from Alex and Oliver, Auf Wiedersehen!